Hello students, welcome to Swapna physics classes. In this lecture I am going to explain you one more important short answer question for your TS IPE first year examination. And the question is define angular acceleration and torque. Establish the relation between angular acceleration and torque. First of all we have to define this angular acceleration and then after torque. Then after we will go with the relation between this angular acceleration and torque. Okay. And what is angular acceleration? Angular acceleration is the rate of change of angular velocity. Change of angular velocity. For example, for a linear motion we will have linear velocity and a linear acceleration, linear displacement, right? In the same way, for a circular motion we will have angular velocity, angular displacement, and angular acceleration alpha. Here angular acceleration is denoted with alpha. Okay. And we will also have angular velocity for a circular motion. For example, I am considering a particle. I am considering a rigid body. For example, I am considering a rigid body. Rigid body is nothing but the particles, the distance between the particles is fixed. The distance between the particle is fixed. It will be not changed. The distance between each and every particle is fixed. It won't changes. Okay. Until a force is applied. For example, a stone తీసుకొని we have a stone for example. If you apply the force on the stone, what happens? It will not deform. The size of the stone will not deform. The size and shape of the stone will not deform. Okay. If you apply the external force until you break this stone into pieces, then only its size changes. But the distance between the particles of the stone remains the same. Okay. This is nothing but a rigid body. This is the example for a rigid body. Okay. And I had considered a rigid body and I just make this rigid body to rotate. I had applied some force on this rigid body and made this rigid body to rotate. This rigid body will rotate about its axis. This is the axis of rotation of this rigid body. Okay, I am considering one of the particle of this rigid body and this particle is initially at point P. As this rigid body is rotating, this particle also rotates about this axis. Okay, this particle also rotates about this axis. This is the path of this particle. The particle is rotating about this path. It's a circular path, right? So, if r is the distance between the particle and center of the circle, r is the distance between this particle and this axis of rotation. Okay, initially the particle is at point P and after some time t, the particle is at point P prime. Okay, initially particle is at P and after some time t, the particle is at a point P prime. Okay, this radius vector makes an angle theta. This makes an angle theta at the center of the circle, right? At the center of the circle, it makes an angle theta. This theta is nothing but angular displacement. Angular displacement. Angular displacement of this particle from P to P prime. Okay. And about the circumference of the circle, the displacement, linear displacement of the particle is taking place. Okay. In our physics definition series, I am going to explain this angular displacement, linear displacement, circular motion of the particle. All the definitions I will explain in physics definition series. Our physics definition series is going to be start from 1st April. 1st April. Okay. So whoever didn't subscribe to my channel till now, just please subscribe to my channel and also click on bell icon for the notifications regarding the physics definition series. Okay, and coming to angular acceleration, here we are going to discuss about the angular acceleration only, not all these definitions. Okay, so the rate of change of angular velocity as the particle is rotating in about the circular path, as a particle is rotating about the circular path, I am considering the small time interval dt. In small time interval dt, d theta is the small angular displacement. Small angular displacement. Displacement. Right? For small angular displacement, we will have small angular velocity. Small angular velocity which is denoted with omega. Okay. Therefore, the rate of change of angular velocity, that means the angular velocity is changing with respect to the time, right? For a small interval of time, we will have a small change in angular velocity omega. Okay, this is nothing but angular acceleration alpha. Angular acceleration is nothing but the rate of change of angular velocity. Angular velocity is changing with respect to the time whenever a force is applied on this rigid body, and with the help of this force, this rigid body tends to rotate about its axis. As this rigid body is rotating about its axis, this body will have angular acceleration and angular displacement. Okay, this is about angular acceleration. And coming to torque, what is torque? Torque is movement of force. One of the definitions of torque is movement of force. Okay, it is given as tau equal to r cross f. The definition is moment of force, and the formula is torque tau is equal to r cross f. This tau is nothing but a torque, which is a vector quantity. Angular acceleration is also a vector quantity. It is also a vector quantity. Okay, torque is also a vector quantity. And one more definition for this torque is the rate of change of angular momentum. Angular momentum, which is denoted with L. Okay, torque tau is equal to dl by dt. For a linear motion, we will have linear momentum P, and for a circular motion, we will have angular momentum L. As the torque is a moment of force, that means we are applying some force on this object which is moving in circular path. Because of this force, we are applying the force F on a rigid body. With the help of this force, this object is rotating about its axis. Okay, if you apply the force at this point, the particles at this point will rotate. These particles will move to some distance. Okay, and after this point, if you apply again the force, these particles again will move to some certain distance. Again you just apply the force. Okay, here the force is also moving. The moment of force is nothing but torque, and the distance is r. Okay, here if the direction of this r is this one, and the applied force direction is this one, okay, and theta is the angle between this applied force and this position vector from the axis of rotation. Okay, then this torque can be written as Rf sin theta. Rf sin theta. Okay, this can be written as R cross F. These are the two different definitions for torque. Okay, one is moment of force is nothing but torque, and the rate of change of angular momentum is also a torque. Okay, these are the definitions for torque. And coming to the relation between angular acceleration and torque. Okay, so we know that torque is equal to dl by dt, and the relation between the moment of inertia and the angular velocity and the angular momentum is L is equal to I omega. We will discuss about this relation and the definition of angular momentum in physics definition series. Okay, so no need of deriving this definition here. This lecture is only for exam point of view. Okay, so if you differentiate this equation, we will have dl by dt, which is equal to I into d omega by dt. Okay, you just differentiate this equation with respect to time. You just differentiate this equation with respect to time. Now this dl by dt is nothing but torque, right? You just substitute here. Torque is equal to I into d omega by dt is nothing but angular acceleration alpha. This is the relation between torque and angular acceleration alpha. Okay, here I will end our lecture. In this lecture, we had defined angular acceleration and torque, and also given the relation between torque and the angular acceleration. Okay, and whoever didn't subscribe to my channel, please click on subscribe button and share with maximum number of people. Okay, bye.